Let us now go through one more new concept, rather important concept, namely numerically greatest terms. Numerically greatest terms. Numerically greatest terms. What do you mean by numerically greatest term? Let us have a look over the expansion. Numerical, what is the meaning of the word numerically greatest term? Look here, 2 plus root 3 whole to the power of 20. What is the numerically greatest term? How many terms will be there? 21 terms will be there. The very first term is 2 power 20 and the next term is 20c1 into 2 power 19 into root 3, 2 power 19 into 1.732, isn't it? Like that, the terms will be increasing and decreasing, like that they will be happening. Out of all those 21 terms, what is the largest numerically that we have to get in this process? There has been a very good process by comparing the r plus 1th term and rth term, and a very good procedure has been designed. That procedure is, look at this, first of all, let us have that in the form of a formula or a pre-designed procedure. And to understand that, let us have the most general expansion. What is that general expansion? To find the NGT in 1 plus x whole to the power of n, or even 1 minus x whole to the power of n. Okay, right, that is the standard expansion. Very first step to be adapted is, you first of all find n plus 1 into mod x by mod x plus 1. That is essential. You name it some p. Some p. Good. Here, two cases will arise. Case 1. P itself is an integer. In this case, there will be two numerically greatest terms, namely Tp and Tp plus 1 are the two numerically greatest terms. Of course, they will be equivalent if you can find them. Actually, as we are interested to consider the numeral value only, we write mod Tp and mod Tp plus 1 are the two numerically greatest terms. Suppose in the other case, P is not an integer. P is not an integer. What happens in this case? This is case 2, of course. If P is not an integer, then automatically integral part of P is an integer. And in this case, there is only one numerically greatest term, namely this. T, integral part of P plus 1 is the only NGT. Is the only NGT. What do you mean by NGT? Numerically greatest term. So first of all, in order to have the numerically greatest term, which term is the numerically greatest term, you must be able to find the value of P. What is P? N plus 1 into mod x by mod x plus 1. Of course, the proof of this particular number is also very simple, but to save some time only, we are just noting it. P is equal to n plus 1 into mod x by mod x plus 1. Automatically, two cases will arise. In case 1, P is an integer, and in this case we have two numerically greatest terms, namely mod Tp and mod Tp plus 1. And in the case 2, P is not an integer, then automatically integral part of P becomes an integer, and hence integral part of P plus 1th term is an integer. is the numerically greatest term. Suppose the value of p happens to be some 16 by 7 or 16 by 5. Then what is the integral part of 16 by 5? 16 by 5 is 3 point something, isn't it? Hence its integral part is 3. Hence t3 plus 1, that is the fourth term, becomes the numerically greatest term. Yes, let us now observe the concept in view of, with the help of a beautiful example, numerical example. Find the NGT in 3 plus x whole to the power of 20 when x is equal to 1 by 2. Let us have the numerically greatest term in the expansion 3 plus x whole to the power of 20. Well, my dear, first of all, we have to look at the expansion. It is 3 plus x whole to the power of 20. It's not in the shape of 1 plus x whole to the power of n. The very first essential thing that you must take care of is you have to have the expansion in the form 1 plus x whole to the power of. That's all. Later only you have to start to do the problem, to solve the problem. Look here, what is the given expansion? 3 plus x whole to the power of 20. This can be taken as 3 into 1 plus x by 3 whole to the power of 20. This can be taken as 3 power 20 into 1 plus x by 3 whole to the power of 20. So the procedure which we could have learnt already, that is by finding the value of p is equal to n plus 1 into mod x by mod x plus 1 and proceeding like that, is applicable only for this expansion only. Yes, let us start with usual notation. What is p? N plus 1 into mod x. What is in the place of x? We have x by 3. X by 3 by mod x, that is mod x by 3 plus 1. This is equal to 21 into, what is x? 1 by 2. X by 3, 1 by 6 by 1 by 6 plus 1. Multiply with 6 on both numerator and denominator. What do you have? 21 by 1 plus 6, it is 7. 21 by 7 is of course 3. 21 by 7 is of course 3. Happy. Again we have the value of p as an integer. Therefore, what are the NGTs? Therefore, T3 and T4. Of course, mod T3 and mod T4 are the two NGTs. NGT in the sense, numerically greatest terms. Well, we could have traced the place or places at which we can find those terms which are numerically greatest. What are the places? Third place and fourth place. If the situation demands, that is, if it is needed in solving a problem to have the term, find it. How to find it? Very simple. T3 is equal to, come on, what type of T3? T3 in this expansion or in this expansion? Both are same. Find T3 here in this expansion and multiply with 3 power 20. Same thing happens. So there is nothing wrong in taking T3 here. What is T3? Come on. 20C3, 3 power 20 minus 3, x to the power of 3. But x to the power of 3 is nothing but half power 3. 1 by 2 power 3. That's it. That is the numerically greatest term. It's very simple. Even if you can find T4, mod T4, the same number is going to be obtained. Yes, that is according to the procedure. Well, my dear, if this particular p is not an integer, what should happen? Well, let us find one such example in which p might not be an integer. Yes. You please observe the style of solving the problem. One more example. Find the numerically greatest term in the expansion 2a plus 3b whole to the power of 15 when a is equal to 1 by 3 and b is equal to 1 by 5. How to proceed? As we could explain for ourselves in the previous problem, the very first step which is needed is you may have to get the expansion given in the form of 1 plus x whole to the power of n. That's all, or 1 minus x whole to the power of n. Let us first do that. Given expansion is 2a plus 3b whole to the power of 15. This can again be taken as 2a into 1 plus 3b by 2a whole to the power of 15, and hence it is 2a whole to the power of 15 into 1 plus 3b by 2a whole to the power of 15. Well, my dear, you might have recognized, it seems, that expansion on which we may have to concentrate. What is the expansion? This is the expansion because that looks like 1 plus x whole to the power of n. And of course, we may have to apply the procedure which we could have already learnt to that expansion. Come on, keeping in view of that expansion, find p n plus 1 into mod x. What is the quantity which is in the place of x? 3b by 2a by mod 3b by 2a plus 1. What is 15 plus 1? 16. What is 3b? b is 1 by 5. 3b is 3 by 5. 2a. a is 1 by 3. 2a is 2 by 3. By 3b by 2a. What is it? 3 by 5 by 2 by 3 plus 1. Good. If this 2 by 3 becomes to the upper side, it becomes 3 by 2, so that it is 9 by 10, isn't it? 16 into 3 by 5 into 3 by 2, that is 9 by 10 plus 1. Multiply with the 10 on both numerator and denominator. What is going to happen? This 10 will be cancelled. 3 into 3, 9. 9 16s are 144. Am I correct? By 9 plus 10 is 19. Observe here, my dear friend, 144 by 19, is it an integer? No, it's not an integer. It is a fraction. It is a fraction. Okay, so the additional burden for us here is integral part of p. What is integral part of p? Integral part of 144 by 19. 144 by 19. Well, how many times will it go? What is 7? 19 into 7. 19 into 7 is, what is that? 70 plus 63, 133. Yes, it goes 7 times. Hence, its integral part is 7. Is 7. Good. What is the integral? What is the largest term or numerically greatest term? T7 plus 1 is the numerically greatest term. Where should you find T8 from this? Of course, after getting T8, in the place of A and in the place of B, you are supposed to put 1 by 3 and 1 by 5 again. That is the way to get it. Got it? You see, this is the way in which we learn the procedure. Once you are habituated to use this procedure, you can come to this value directly. After noting it, what is the term which is numerically greatest, you can easily estimate. That's it about this topic. You understand, try to follow this in your, and you try to keep this in your mind. In this session, we shall go through some more special features in binomial theorem. In that aspect, let us observe this problem. Observe the expansion root 2 plus 3 into cube root of 5 whole to the power of 60. Observe the expansion. And you are asked to have the number of integral terms in this expansion. How to do that? Let us first observe the theoretical part behind the procedure. Look here, the expansion contains 61 terms, of course, in which the r plus 1th term is tr plus 1 is equal to 60 cr 2 power half whole to the power of 60 minus r into 3 into 5 to the power of 1 by 3 whole to the power of r. On simplification, it becomes 60 cr 3 power r 2 power 60 minus r by 2 into 5 power r by 3. Good. 60 cr is an integer, 3 power r is an integer for any integral value of r. And now, if you want to see this term entirely an integer, then this and this must be integers. That is 60 minus r by 2 and r by 3 both must be integers. Well, what is the LCM of 2 and 3? It is 6. If you place r is equal to 0, 60 by 2 is 30, an integer. If you place r is equal to 6, then 60 minus 60 is 54 by 2 is an integer, like that. So even here also, if you place r is equal to 6, 6 by 3 is an integer. Of course, if you put r is equal to 3 also, then this becomes an integer, but this does not become an integer. Both of these 60 minus r by 2 and r by 3 must become integers, and that can happen when r is a multiple of 6, 0, 6, 12, 18 and so on. So this becomes an integer if and only if r is equal to 0, 6, 12, 18 and so on. How many will there be in number? It's very simple. 60 by 6 plus 1. Why plus 1? It is true when r is 0 also, isn't it? Yes, of course, since the answer is 60 by 6 plus 1. What is the integral part of 60 by 6 plus 1? It is 10 plus 1. How many terms will be there? Here, see, if you take r is equal to 0, 60 by 2 becomes an integer. Suppose you have, say, 51 instead of 60. What happens? 51 minus r by 2. You see, the integral part of 651 by the LCM of these radicals. Yes, like that. In any case, this becomes the answer. What is the total number of integral terms of this expression? It is 60 by LCM of 2 and 3. This is square root of, this is cube root of. What is the LCM of 2 and 3? 6 by 6 plus 1 becomes the total number of integral terms of this expression. Well, my dear, you see, it is not needed at all to have a formula for this. It is an easy matter to look at, of course. So there is no need to construct, rather to design a formulatical view for this. It is just enough to understand the concept. Well, let us look over one more such concept. Please go through the problem and understand the concept in your mind. You keep it in your mind.